Hi all, I'm Nitesh Goyal and welcome to our channel ML for Analytics. In this lecture today, we will be studying about sorting arrays in NumPy and few functions that we can use through NumPy. So two of the major functions that are used for sorting the arrays are sort and argsort. So let's study the sort first. And this is the syntax for the sort function, that is arr x is equals to -1, kind equals to quicksort, order equals to none. So what are these? The first over here, ARR, is the array that you want to sort, and axis defines that along which axis you want to sort the array. For example, if you are given a 2D array, you want to sort it with the first axis or the second axis. By first, I mean like vertical axis or the horizontal axis. So depending upon the dimensionality of the array, these number of axes will increase. And the kind over here describes us that which sorting technique that we want to use for sorting our arrays. By default, the value is quicksort. However, we can use two more techniques, that is merge sort and heap sort. So we will be comparing their performance in this article, or in this lecture you can say. So stay tuned with me for that. Order equals to none. So what is order? It is not very useful for us. Still, let's understand what it is. It takes the input in the form of list, and it is only used when we are passing an array which is in structured form. It specifies that which fields to compare to sort the array, like first field, second field, or third field, and many more. So we will not be covering this order part in this lecture. However, the other three will be included in this one. So let's begin with creating our sample array. And this is a jumbled array, or a 1D jumbled array, I would say. And let's try to sort it with the directly np.sort function. And as you can see, just on a click, it got sorted very well. Now, by default, as we know, it used the quicksort function. What about the other two? And what are their performance over quicksort? Or is the quicksort is the best one? So let's see that as well with the timeit function of the IPython. And for that, first of all, I'm creating a huge array, or which will contain the random values up to 10 million. No, actually the values will be like 1 to 100, but the number of values in that array will be 10 million, or you can say the size of array is 10 million. So let's click it, and we have got an array having size of 10 million, and these are the jumbled array values, all of integer type, as we are using the randint function. And let's time the quick sort function over here. Okay, so it is taking some time. Okay, it took around 607 milliseconds to sort this 10 million values, so which is a very good performance, I would say, because 10 million values is quite a huge amount. And let's try this for the merge sort, and all you have to do is like provide the array and kind equals to merge sort. So as we studied over here, kind defines it which sorting technique we want to use. So that's what I'm using over here, kind equals to merge sort, and let's time it. It took around 1.2 seconds, which is just double the quicksort time. So you can say quicksort has very high performance or better performance in comparison to merge sort, and these were for like 10 million values. But when we come to our systems or mobile systems, we come across billions of operations per second. So in that case, quicksort is very huge, very useful, and very powerful tool to us. And let's check for heap sort as well. It took around 1.48 seconds, so which is even greater than the merge sort. So if we talk about the performance, this should be our metrics, like quicksort the fastest, then merge sort, and then heap sort. But one thing to note over here is, as per the testing done by several engineers and scientists, quicksort and heap sort are not very stable when it comes to huge competitions of the systems. So the most preferred method over here will be the merge sort. Though it is bit slower than quicksort, but if you want the stability in your system, try using merge sort only. Now, what is the difference between np sort and our np.argsort functions. Why do we even need to use the argsort function? I would say it is not much of a big difference. The sort function was providing us directly values in the sorted format. However, if when I use the argsort function, it provides me only the indices or the position of the sorted values. Like if I am given an array of 10 elements, and if I use the argsort function, it will provide me the position of the values of the existing unsorted array, and in which way those values should be put, or or provide me the positions of those unsorted array, which should ideally be in the sorted array. So let's see the example to understand it better. Now this provided me the values like indices corresponding to our main array, that is this one. So basically the position of all these values, like for the one, the first position is this one, and this should be the first position over here as well, that is the 8th element. So that's how it is working. Now to understand it better, let's print the values corresponding to those indices, and these are the values for them. So you can clearly see that argsort is also sorting the array. The only difference over here is instead of getting the values, we are getting the indices or the position of those sorted values. Now let's try sorting the values across different axes. Like as I said in the starting of the video, for a two-dimensional array or a multi-dimensional array, we can sort values across different axes like horizontal axis, vertical axis, and whatever you like. So for let's start with the x is equals to 0. For the vertical axis, or if I said I want to sort values across columns, the x's value is 0. So let's create a 2D array for that, and this is a 2D array. So by vertical axis, I would say like this, the first column 5, 9, 8, 8, then 9, 13, 11, 6. So values should be sorted column wise, but not across the rows. So let's try printing the values for it. Okay, as you can see, the values are not sorted across the row. However, for each column, the values are being sorted in ascending order. 5, 8, 8, 9, 6, 9, 11, 13, 5, 10, 11, 12, 8, 9, 13, 13. Now, what if I want to sort the main array across the horizontal axis or along the rows? So, here comes the second part. We set the x is equals to 1. So as the dimensionality of the array increases, the value for the x is also increases. If it is a two-dimensional array, the x's value can be 0 or 1. If it is a three-dimensional array, the values can be 0, 1, and 2, and so forth for as per the increasing dimensionality. So let's sort it across the row, and here it is. The values are now sorted across the rows, but not across the columns. So that covers our basic sorting techniques in NumPy. In our next tutorial, and we will be covering more techniques like indirect sort or the leg sort and many more in the NumPy sorting. So stay tuned with me, stay tuned with the ML for Analytics. Do comment and please do let me know in case you want to study something special from us. Thank you very much.